Hi, it's me again, Base. Today I would like to start further math walkthrough now. This is the further math paper FP1 and I hope this walkthrough will be helpful for you. For those of you who are looking forward to the next paper, FP2 as well on the same year, you should stay subscribed, or if you haven't, please subscribe. Are you ready? Let's go. Let's start with number 1. Part A. Given that y equals ln of 3 plus x squared, complete the table. Alright, so the table here is missing the y for x equals 3, so we're just going to plug 3 into the equation there. So y equals ln of 3 plus 3 squared, and we're going to use a calculator, of course. So ln of 3 plus 9, right? So that's going to be 2.485, the 4 significant figures, yeah. So that's it for part A, easy. Now part B, using Simpsons rule with all the values of y in the completed table to estimate to 3 significant figures the value of that integral. Alright, so let me just copy the table and show you how I would go with this. Yeah, it's just the easy way to maybe memorize the formula. Okay, so that's the table there. And you can do that in the paper, right? I'm just using this feature here, copy. Now it's similar to trapezium rule here. It's just that instead of a half, you multiply by a third, and then of course the strip width, which is 0.5, right? And then in the big brackets here, you would have to add the first one, which is 1.946, with the last one, which is 3.332. And then now there are 2 other groups. The first group, if you label the number here, 0, 1, 2, 3, 4, 5, 6, we take the odd ones, which is this one, and this one, add them up and multiply by 4. So that's just it. Yeah, this is the odd ones. And then the even one, we add them up and multiply by 2. So that will be this one, yeah, the number 2 there, which is 2.485 we got earlier, and plus 2.944, right? So this will be the area, the estimated of the integral there. So that's going to be using a calculator, right? So 1/3 times 0.5 times brackets 1.946 plus 3.332, yeah, plus 4. I'm just going to put brackets like that first, and plus 2 brackets to, you know, not confuse myself with the brackets there, and then close bracket, and I'm going to fill in the number in here, yeah. So that's just 2.225 plus 2.725 plus 3.146, yeah. The other bracket there, 2.458 plus 2.944. Yep, so that's 8.0. So what do we do? 3 significant figures. So 7, 7, 6, 6, blah, blah, blah. So that's 8.08. That's it, yeah? And that's part B done. Part C. Using your answer to part B and making your method clear, estimate the value of that. Right, you see the difference here? This is just like pure math actually. They play with when after you have found the estimation of an integral from some numerical method. Simpsons rule is the numerical method, just like trapezium rule. And then they're going to tweak the form, tweak the integrand here, which is inside the integral, to not being exactly the same but still similar. So that thing that we want to find in part C is the same as to put that as a power of a half, right? That's not too bad. So we can use a log property to bring the half down. So it's just going to be a half outside everything, like that, right? In which we already know this integral, that whole thing. We found it in part B, so that's going to be a half times 8.08. So that's just 4.04. Yeah, that's it. My method should be clear, right? So that's question 1 done. Question 2. Use algebra to determine the values of x for which that, right? So if we plot the graph roughly, right, that is, if we just look at the left hand side, we have a quadratic function which is x. If you factorize that, you're going to get x times x minus 2, right? And the other one is just linear, so I'm going to draw a linear first. That's the right hand side. And this is just a quadratic where the x-intercepts are just 0 and 2, right? And it's a normal parabola, so it's going to look something like this, without the modulus sign, of course. Now you have a modulus sign, so it's going to look maybe more like that, okay? Now we should be thorough here because, because the curve there might be even below the line. We don't know, right? So if we just get a rough idea about the vertex of the parabola, so the vertex should be, because this is at 0 and 2, so the vertex should be at x equals 1, right? Because you just do 0 plus 2 divided by 2. Now, if we plug 1 back into the function of the parabola here, the function of parabola, with the absolute, of course, what are you going to get? You're going to get 1, right? Now, you get 1, and that is probably, that happens to be the solution. It's this intersection. It's just coincident. I didn't mean to just know that it should be 1, because I want to try look if the curve is above or below the line at x equals 1. Now it turns out that if you put x equals 1 into the linear function, which is y equals x, this is the linear part, well, that's going to give you 1 and 1, right? If you put x equals 1, you're going to get y equals 1. If you put x equals 1, you also get y equals 1 for the quadratic. So they do intersect here then, right? Just coincident here. Okay, so but we need to show the step there. Okay, so I just proved that the curve does cut the line at that point, right? So we need to show the working step. So at first we know that, okay, there is so I'm just going to write here intersection. Yeah, 0, 0 is obviously the answer there, okay? And then we have 1, 1. Well, but let's just try do x. There should be a negative sign here because this is an inverted parabola, right? So I'm just going to do minus x squared plus 2x. So just basically taking the modulus sign out and put the minus sign in front of everything. And then we put equals x, right? Yeah, to find the solution here. So we would have x squared minus x equals 0. So x and x minus 1 equals 0. So x equals 0 and 1. Right? So the next point is 1 and 1. Yeah, so the 1 here comes from that. There's another point here where it may cut, right? Gotta be careful here. Also that. Alright? Yeah, we also need to find that. So the other solution for that would be, well, that's the normal x and x minus 2, right? Without the modulus sign, of course. And we put it equal to x. So this is x squared minus 3x now, right? If we move also the other x there. So I have x equals 0 or 3 if you solve that quadratic. So this is where x equals 3. Y would also be equal to 3, right? Okay. So the part where the modulus graph is below the x is this. Yeah. And that's it. Because this is above, this is above. Oh, we got to be careful because it's also equal. So 0, 0 is also the answer. So I'm just going to write here, yeah, x equals 0. Or 0 is the answer. Why is it the answer? Because don't forget, we have an equal sign here in the inequality. So the part where x and like they intersect here also count, right? Yeah. Okay. Now this part, right? So it goes from 1 to 3. So we got to put less than 3, greater than 1 with an equal sign on each side. Yeah, like that. And that's it. Because we want where the modulus is below or equal the line. Yeah? So that's my answer there for number 2. Would be this, yeah? Okay. Next question, number 3. Use L'Hopital's rule to show that blah blah blah. Okay. So we use L'Hopital here. That means we need the proof first. So usually it's either denominator and numerator both 0 or both infinity or minus infinity. But in this case, if you look at the expression here, if you don't do anything to it, it's impossible to get 0 or infinity at the numerator. So we need to simplify or derive first. So if I do cross multiply that, I get x minus sine x. And the bottom will be x sine x, yeah? Okay? Now, of course, now if you try put 0 in both numerator and denominator expressions, they're going to go to 0 now. Okay? So you do like lim x go to 0 of that would be, you know, because the rule applies now. So we differentiate, right? So we differentiate the top part and the bottom part separately. So the top part we have 1 minus cos x, differentiating side we get a cos. And we're going to use a product rule for the denominator. So differentiate x and keep the sine x the same, plus differentiate sine x, we get cos x, keep x the same. Yeah, so that. Okay, now we apply, we substitute 0 in. Do we still get 0 on top and bottom? Well, we sub 0 in here and 0 in here. Yeah, we still do. So we keep differentiating again. We differentiate 1, we get 0. We differentiate cos, we get a minus sign, so that becomes just a sine. We differentiating sine at the denominator, we get a cos here. We differentiating cos x times x, so that's a product rule again. So that's cos x, and then differentiating x, we get 1. I'm just going to move a little bit here. And then the other term would be differentiating cos, we get a minus sign. And x doesn't differentiate, so we keep x the same. See if it works now. Well, I get 0 again here, but I don't get 0 at the denominator now, because this will go to 0, right? But this won't. So that will be 0 over, what's that? 2, right? So the answer is 0. Yeah? Because you need to keep differentiating until, like, when you substitute, it doesn't give you 0 over 0. Now this time, it only gives me 0 at the numerator, but the denominator, it gives me 2. So you can't now use L'Hopital another time. You got to stop here. So that's it, number 3. All right? Next, number 4. The Taylor series expansion of f(x) about x equals a is given by this. All right, we know this, right? The curve with equation y equals fx satisfies the differential equation that, given that pi over 4 and 1 is a stationary point of the curve. Okay, determine the nature of this stationary point, giving a reason for your answer. So basically, we need to find the second derivative. Yeah, knowing the first derivative. So okay, this is part A, at pi over 4 and 1, because this is a stationary point, so dy by dx equals 0, right? So we're going to plug in x as pi over 4 here. That's why I got cos pi over 4. And dy by dx will have to be found. But that will go to 0 there, the second term. I'm using the differential equation there. And plus sine pi over 4 equals 0. So we are solving for the second derivative here to see the nature at this point, right? So cos pi over 4 is 1 over root 2, yeah? Just writing down. Sine pi over 4 is also 1 over root 2. Okay, that makes it easy. So we subtract by 1 over root 2 on either side, and then we multiply across by root 2, so we're going to get d squared y by dx squared equals minus 1, right? Yeah? So because minus 1 is less than 0, so therefore it is a maximum, isn't it? Yeah, maximum. Yeah, because the rate is decreasing. Yeah, it's a maximum. Yeah, that's the nature of a turning point. And we already state the reason here because the second derivative is less than 0. Okay, B, show that the third derivative is that at this stationary point. So at this stationary point, we need to find the third derivative. Okay, so we can do that by implicitly differentiating all this, right? Yeah, we're going to differentiate all this. So yeah, just basically differentiate respect to x, the whole equation implicitly. So that's going to give me, okay, so I'm going to do product rule here, cos x d cubed y by dx cubed. That's product rule. And then that's u dv, and now v du, so minus cos, minus sine x, second derivative. Yeah, that's the first term done. Just the first term there. Let me just get some more area here. And then the second term, so y squared d squared y by dx squared, yeah, plus 2y, because we are differentiating respect to x, right? So that's going to be another dy by dx times dy by dx. So that's going to be dy by dx overall squared, all squared like that. Yeah. And then differentiating sine x, we get a plus cos x, and the other side is 0, right? I hope you can see that. Okay, let me move a bit. Equals 0 here, yeah? All right. And now we're going to substitute in term by term. So cos pi over 4 is again 1 over root 2. And d cubed y by dx cubed here is the thing we want to find. Minus sine x is also 1 over root 2. D squared y by dx squared is minus 1, right? Plus y squared, y is 1. D squared y by dx squared is again minus 1 here. Yeah. Plus 2y. Oh, that thing's going to be 0, right? The whole thing here, because we have dy by dx. And cos pi is again 1 over root 2 equals 0. All right? And, well, that's going to be 1 over root 2 there. That's going to be minus 1 there, 1 over root 2 there. So all the number term or the constant term on this whole side will be what? So that's going to be plus 2 over root 2 minus 1 equals 0. That means if we rearrange, make the third derivative here the subject, we're going to get 1 minus 2 over root 2 times root 2, and that would be root 2 minus 2, which is what we want, right? Exactly. Okay, that's good. Part C. Hence determine a series solution for y in ascending powers of that. Right. So if you see an ascending powers of something not x, we're going to put the critical value of these brackets to the a. So a here is going to be pi over 4, right? And then because we want the series solution of the differential equation, right? Yeah. The series solution for y, yeah. So let's write down the Taylor series for this first. So it's going to be y equals y naught plus x minus a, yeah, which is x naught, and then dy by dx at a plus x minus a squared, d squared y by dx squared at a. We have to do up to the third term, which is also x minus, oh, forgot to do over 2 factorial here, and then x minus a cubed, and this is 3 factorial, d cubed y by dx cubed at a, and then that's it. I think we stop there, right? So y0 is just y at x equals pi over 2. We already know that, because at x equals pi over 4, sorry, y equals 1. So we're going to put 1 there. Okay? X minus a in this case would be x minus pi over 4, of course, because that's the form we want here. Okay? dy by dx at x equals a is 0, because we know that at this point is a stationary point. So dy by dx is 0 here. So that vanishes. That's easy. But we write the working anyway. And then we have x minus pi over 4 over 2 here squared. This is the second derivative, so it's minus 1. Yeah, it's still the same point here. That's easy. That's why it's 2 marks. And then the last one, x minus pi over 4 cubed divided by 6, because that's 3 factorial. And then the cubed y by the x cubed here would be root 2 minus 2. And then we simplify that. Okay, so it's going to be 1 plus, well, minus, because we have a minus 1 here, so that's minus 1 over 2, x minus pi over 4 squared. And what about this guy? Well, I'm not going to split the term there, so I'm just going to write like plus root 2 minus 2 over 6 pi x minus pi over 4 cubed, like that. Okay, so we already simplify the coefficient in each term. That should be fine. So that's the y there. Okay, that's the series solution of it. Okay, that's done for question 4. Next, question 5. We have y equals e to the 3x sine x here. A used Leibnitz's, he who also invented calculus, theorem to show that the fourth order derivative of this is this, right? So Leibniz, right? So we don't have the formula in the formula sheet. Okay, Leibniz is the nth order derivative of y respect to x here is going to be, it's similar to a binomial coefficient, right? So it's going to be the sum of from r equals 0 to n. Yeah, it's going to be like a binomial. So we do n r here, and then the first one will be d. So if y is u times v, yeah, where u and v are both functions of x. So this one we have the rth order of derivative of u first, like that, times the what n minus rth order of v, the derivative of v, like that. Yeah. So if r equals 0, right? If r equals 0, the coefficient will be 1. This is the binomial coefficient, the NCR, right? So NC anything, sorry, NC0 is going to be 1. Yeah. So you get 1 here when r equals 0 times d0. So when r equals 0, when you have d0 there to the power of 0 like that, that means 0 order derivative. That means nothing. It's not nothing, it's not 0, but it's just you don't differentiate the u, so you just get the u. So that will just be just u times. So what's that? The fourth order, right? I'm just going to expand here first to see what we should get, right? What we should differentiate and get before differentiating anything. Just like plan first, yeah? So n minus r is going to be the fourth order for v. Like that. Okay, so that's the first term. The second term, r equals 1, so that's going to be the first order of u. Hang on. So when r equals 1, we get nc1, so that's going to be 4, right? Okay, and then this is r, the first order of du by dx, and then times the fourth order derivative of v, right? Wait, sorry, no, the third, because it's 4 minus 1. Okay, And then it's gonna keep going with the same pattern here. So the next one will be n 4c2. 4c2 is 4 times 3 over 2, so that's 6, right? Yep, 6. And this will be to the second order. And that will also reduce to a second order as well. Next one is 4, and the u will become the third order, but the v will be just the first order. And the last term is, I guess, just v, right? And then now the u will be the fourth order. Yeah, so we should swap the term there, like that. Okay, so that's just expanding all out first to see what we should get. And then I'm just gonna find each one that we want. So if we put u as e to the 3x and v as sine x, right? Yeah, so du by dx is just 3e to the 3x. D squared u by dx squared will be, differentiate again, we get 9e to the 3x. D cubed u by dx cubed, we get 27e to the 3x. And then, yeah, it's the same pattern. It's not hard for this. D to the 4u by dx to the 4 would be, what's that, 81e to the 3x, yeah? That's just for the u. For the v, so we have v sine x, so dv by dx is cos x. D squared v by dx squared is minus sine x. D cubed v by dx cubed would be minus cos x. And then the fourth v by dx fourth will be sine x, right? Because the minus sign cancels there. Let's see what we get here out of that whole thing. So here we still find d to the 4y by dx to the 4 equals, right? The first term is u times d to the 4v by dx to the 4. So u is e to the 3x. D to the 4v over dx to the 4 is sine x, okay? The next term is 4 du by dx is 3e to the 3x. I'm just going to write down everything and simplify all at once, right? dv cubed is minus cos here, yeah? Plus the third term 6, d squared u by dx squared is 9e to the 3x. And then d squared v by dx squared is minus sine x. And then write down here, the next term 4 times d cubed u by dx cubed is that. dv by dx is cos x. And then the last term d to the 4u by dx to the 4 is 81e to the 3x. V is just sine x, right? Yeah, just the beginning. Okay, so if we collect the terms, right? Looking at the question here, they split into e to the 3x sine x and e to the 3x cos x. So let's look at the sine x first. So we have, I'm just going to write the term here and just collect the numbers. So we have 1 here. And what is that? Minus 54. So that's just going to write like this maybe. So we have 1 minus 54. And then we gotta get 28, so, and another 81 here, yeah? And the other one would be e to the 3x, let me just, yeah, and cos x, right? So what do we have? For the cos, we have minus 12, yeah, from this. And then this one is what? 4 times 27, that's 108, right? Yeah. Okay. So this is what? That should be 28. Yeah, this one should be 28. And the other one is 96 indeed. Okay, so we get what they want as required. B. Hence express d to the 4y by dx to the 4 in the form of that. Right, so we're just gonna convert that into this, right? And that looks like it's a harmonic form, guys. That's pure math, right? Yeah, sure. So we do, hang on. Yeah, so we're just gonna put 28 sine x plus 96 cos x equals r sine x plus alpha, right? Just that. This is pure math. And then, so what do? We separate that into r sine x cos alpha plus r cos x sine alpha, right? Yeah, just closing into the edge there. Too close maybe, hang on. Yep. Okay, and then we can compare that 28 equals r cos alpha and 96 equals r sine alpha. So r would be the square root of 28 squared plus 96 squared. 28 squared plus 96 squared, we get 100. That's perfect. And then I'm just going to do alpha. We want the radians, right? So that's just arc cos of 28 over 100. Yeah? Okay, constant to be determined. That's fine. So radian arc cos 0.28. That's 1.287. Just going to keep 3 decimal places then, because that's like the usual number they want. Okay, so then that would be, therefore, d to the 4y by dx to the 4 would be equal to 100 e to the 3x times sine of x plus 1.287. Okay, here we go. That's it. Next, number 6. The ellipse E has an equation that the hyperbola H has an equation that, where A and B are positive constants, given that the eccentricity of H is reciprocal of the eccentricity of E. I think this style has come out before in the 2022, I think, where they give you ellipse and hyperbola, and then I think it was E1 times E2 equals 1, if I'm not mistaken. But in this case, we're going to put ellipse as E1 and hyperbola as E2 then. And then they say that the eccentricity of H, which is E2, is the reciprocal of E1, like that. The coordinates of foci of H are the same as the coordinates of foci of E. Okay, so just the two focuses, right? Okay, so that's saying, okay, we should get the information for each one first. I'm just going to put the E there, and then for the ellipse, we know that the thing that is greater and beneath the x squared there would be the A, the major axis, right? So A is just square root of 25, which is 5, and B would be square root of 9, which is 3. Okay, now the easiest way I would do this is to get the what's called the C first. This is not in the textbook, but for an ellipse, A would be the longest. There are A, B, and C, yeah? For an ellipse, A would be the longest, and then you do a Pythagoras. So to get C, right, it's going to be square root of A squared minus B squared, because A is like a hypotenuse, because it's the longest for ellipse, yeah? But for hyperbola, C is the longest. That's just the way I go with this, right? So what's with the C? Well, the C is just the distance from the center to the focus, to either foci actually, either focus, okay? So this is square root of 25 minus 9, which is square root of 16, so that's going to be 4. Yeah? And this happens to be A times E for the ellipse. So because A is already 5, so therefore E is 4 over 5, right? Eccentricity of the ellipse is 4 over 5 then? Well, we can do the same for hyperbola here. Yeah. So the c of the hyperbola will be a square root of a squared plus b squared, because they already give you a and b there. Okay. And the c here also happens to be ae, right? And ae here is, I'm just going to do a squared e squared equals a squared plus b squared, right, for the hyperbola here. And because you already know E2 as well, so E2 is just going to be 1 over E1, which is, that's E1 there, 5 over 4. Yeah? So we're going to put 5 over 4 here into the E2, that's E2 there. So it's a squared. 5 over 4 squared is just 25 over 16, so I'm just going to put that, equals a squared plus b squared. So basically here we get a in terms of b for the hyperbola there, right? So if we subtract both sides by a squared, so we're going to get 9a squared over 16 here equals b squared, right? Just subtract 16 over 16a squared to the left side. And then that's it. So that's 9a squared equals 16b squared. We're going to come back to that. Now, we want to put the numbers to this, right? So let's see what we have. They told you that the foci are the same, right? So AE of the hyperbola will be the same as the AE of the ellipse, right? We already know the ellipse to be 4, AE. So I'm just going to put AE2 equals 4 here. Yeah. And E2 is, again, 5 over 4, right? Equals 4. So A of E2, A of hyperbola, sorry, it's going to be 16 over 5. Yeah? Okay. And now we can find out B. So if A is 16 over 5, then, okay, we know A squared, right? So A squared is going to be then 256, I believe, over 25. So B squared will be 9 over 16 times 256 over 25. That's going to cancel 16. So that's going to be 144 over 25. Yeah. Oh, we're going to solve for A and B, right? So therefore, A equals just a positive number because A is the length of the major axis. It's half major axis. So A in this case would be, we already got it here, 16 over 5. And B would be 12 over 5. Yeah, that would be the answer. All right, that's not too bad. Number 7. Okay. Use the substitution. Okay, so this is Weierstrass. I can't pronounce his name, but yeah, there you go. Use substitution t equals tan theta over 2 there to show that blah blah blah. Okay, so we should get first that if that is tan, if t is tan theta over 2, then the double angle, right, of sine theta would then be 2t over, I believe, 1 plus t squared. We can quote this formula without having to prove. Actually, you can prove using a right angle triangle and double angle formula. And then the cos, right, would be, I believe, t1 minus t squared over 1 plus t squared. And that's it, right? So part A here, yeah. So integral of 1 over, so I'm just going to write 1 over 2 and then just substitute sine already here, yeah, plus a cos, so which is that, okay, and then plus 2, just going to write that first, yeah, d theta, that's fine. Okay, so we need to also do differentiation for the t there. So dt by d theta here is going to be, differentiate tan, you get a sec squared, okay, and then it's going to be a half as well because you have a chain rule. So sec squared theta over 2, and then this is a half, okay. that means the theta as a subject would be 2 over sec squared theta over 2 dt. Yeah, but then the sec squared there is 1 over cos, so that's going to be just cos. So the theta here is just 2 cos squared theta over 2 dt. Well, because tan is t, right? So you can draw a little triangle here. If they give you tan theta over 2 here, the little triangle there, for the angle here being theta over 2, and this is a right angle, because tan is TOA, opposite over adjacent, so we can put t over 1 like that. That's just a little neat trick there that I use all the time, not just in pure math but also in mechanics and others. And then the hypotenuse here would just be a Pythagoras of t squared plus 1, right? Well, that would then be what? The theta is 2 times, well, we have a cos squared here, so that's going to be 1 over square root t squared plus 1 squared. So that's going to be 1 over just 1 plus t squared here dt. And we're going to put that here, right? So 2 times 1 over 1 plus t squared dt, all that. Okay? So if we simplify the denominator here of the main part, I'm just going to put 2 here first. So we will also have denominator in here, yeah, which is 1 plus t squared, which cancel with the 1 plus t squared here, yeah, cancel with that, right? And the top bit here will just be this 4t, right, plus this 1 minus t squared. And if we multiply 2 by 1 plus t squared on top and bottom, we are going to get plus 2t squared, yeah? And that is just dt and the integral, all right? So that cancel, of course, yeah, we like that. And then the bottom bit, what do we have left? So it's just 2 divided by 2, how many t squared there? It's 1t squared, okay? And then plus 4t plus 3 dt. Seems like we need to complete a square there, so that's just 2 squared plus 4t plus 4 minus 1, yeah? Because I want to make this a complete square, so that's why I split 3 to 4 and minus 1 there. So that's going to be a complete square of t plus 2 minus 1 like that. And that is as required, yeah? B. Hence show that integral of that is that. So for this integral, right, if we look at the answer they want here, it's a natural log. So we should look at our latest integral here as 2 over t plus 2 squared minus 1 dt. And then if we open the formula sheet, let me just open that, okay? If you look at the formula sheet here, which one do we have the most resembling the natural log, right? It's kind of this one, right? Because this one is x squared minus a squared, yeah, but this one is minus x squared. So if we look at t plus 2 as an x and a as a 1 here, right? So I'm just going to say here x equals t plus 2 and a equals 1. So x squared is just that squared and a squared is 1 squared, or still 1, yeah? So that's going to be equal to 1 over 2 times 1, right? Ln of t plus 2 minus 1 over t plus 2 and plus 1, right? And then we have a 2 outside as well, right? Because this is just for that, yeah? This is just for that. So we have a 2 here as well, so I got to put a 2 here as well, right? And then we just simplify, and then we put on the limits, right? Here, don't forget that t is still the tan theta over 2, Yeah, so we should find the bounds for t as well. That means if theta equals 2 pi over 3, then t will be equal to what? So 2 pi over 3 plugging in here, 2 pi over 3 divided by 2, you get pi over 3. 10 pi over 3 would be root 3. Yeah? And then if theta equals the lower limit, pi over 3, t will be equal to, well, 10 pi over 4 is 1, right? So that's 1. So the limits will be 1 and root 3 here, right? And then we just, well, the 2 can cancel here, so that's no problem. So we have ln of modulus. You put root 3 in there, so you get root 3 plus 1 divided by root 3 plus 3 for the first one, and minus ln of, so that's going to be 2 over 4, right? And let's see. Yeah, all of them are positive numbers, so we don't need the modulus sign there. I'm just going to simplify, so this will be ln. So actually, we could do root 3 plus 1 divided by root 3 plus 3. Yep. And because this is a minus, right? So we can put a divide here. 2 over 4 is 1 over 2. Because that's a division of a fraction, then we can flip and we can say this is 2. Right? And now we will probably have to rationalize that. So if we rationalize just the fraction there, see what we get. Root 3 minus 3, root 3 minus 3. So we're going to get 3 plus root 3 minus 3 root 3 minus 3 divided by root 3 minus 9, that's minus 6, right? So that's going to be, the 3 goes away, and then we have minus 2 root 3 over minus 6. That's root 3 over 3, right? If you simplify that, which is 1 over root 3. Yeah? Or I'm going to keep root 3 over 3 because they have root 3 over 3 there. And then hence it's going to be equal to ln root 3 over 3 times 2. Or just put it exactly as they want there, 2 root 3 over 3. As required there. So that's it for question 7. Question 8. The parabola P has equation y squared equals 4ax, where a is a positive constant. The point A, blah, 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 where t not equal to 0 lies on P. Right. Use calculus to show that the equation of tangent. Yeah, they would like to, play with this quite a lot. Yeah, you have done PO2 now, so you know implicit differentiation. So I'm going to differentiate the parabola equation implicitly. So I get 2y dy by dx, because I don't remember the formula, so I'm just going to do that all the time. Yeah. And then that's it. And then, so dy by dx will be equal to 4a over 2y, which is what? 2a over y, right? Yeah. So we're going to find the gradient first. So dy by dx is going to be 2 times a divided by y, which is 2at. Yeah. The question gives you 2at there. And then just simplify this. We get, so a cancel, 2 cancel, we get 1 over t, right? Okay. And then we just use y minus y1, in this case 2at equals m, which is, that's a tangent, so it's still 1 over t, x minus at squared. Multiplying t out, we get yt on the left side, yeah? Just multiplying t out across. And then minus 2at becomes minus 2at squared. We move it to the right. So that's minus 2at squared. And then the x plus x minus at squared. And then we simplify that. We just get x plus at squared as required. Yeah, easy 3 marks there. Part B. The point B, blah, blah, and point C, blah, blah, where k is a constant, lie on P as well. The tangent to P at B and the tangent to P at C intersect at point D. Right. Given that the area of the triangle BCD is that, determine the coordinates of B and the coordinates of C. So if we draw a parabola, I would like to visualize by drawing first, because I noticed that the x values are the same for B and C. So they are on the same vertical line and just opposite side basically. So if this is a parabola, it should be, assuming it's a normal, you know, rightward parabola like that, yeah? Because we don't have any transformation here, it's a normal parabola, like on the side. And A is this distance, right? This is A, little a here, yeah? So we have the point B and C on the parabola where they're on the same, you know, vertical part, like vertical alignment. So let's say B is there and C is there. Okay, so this is 2k squared. We don't know what k is yet. It might be 2k squared might be greater or smaller than a. We don't know. We're just going to leave it like that. But we know that this is 4k and this is minus 4k, right? And where's point D? Because that's B and C, and the tangent intersect that point D. So I'm just going to use a different color, drawing the tangent there. So I think this should intersect that like halfway, yeah? Intuitively, they should intersect at the x-axis. Because like B and C are exactly on the same, like, you know what I mean, right? It's on the same, you know, vertical alignment. So when you draw a tangent, their gradient should be the opposite. Like one is positive, the other is negative. So they should intersect on the x-axis. That's the logic there. Okay? If you use some logic in math, it's going to make it easier, guys. You don't need to use algebra all the time. So here I'm saying that because that is assumingly point D, and you want BCD, the area of it. And that's just easy now. Right? Let's see if it's actually easy. So yeah, we probably have to find point D anyway. But once we found point D, then we can find this distance. We kind of know the height. So after we found point D, then it would be just home free. So let's just start from dy by dx, right? Equals, I'm just going to find the tangent for B alone, right? So dy by dx will be 2a, because that's the parabola equation, over y, which is 2a over y is 4k, so that's going to be a over 2k. Yeah? Okay. And then again, y minus, we want to find point D, right? So we can do that already. So point D, we know that the x coordinate is non-zero, and then the y coordinate is 0. But we want the xd there, the x coordinate of D. So I'm just going to leave it as xd. Now if we put in y minus y1 equals mx minus x1, we can already put also, you know, the 0 to the y here and the x to the x here. So that will allow us to find xd already without having to find the equation first. So 0 minus y1 would just be point D, because this is the tangent at point D, right? So B is y1 is 4k, yeah, point B. M is already found, a over 2k. And x is the xd. x1 will be 2k squared. That's of point B, yeah? Okay, if we solve this, we should get xd in terms of k and a, right? Yeah, so let's do that. So that's going to be, if we multiply out by 2k, we get minus 8k squared here equals axd. No, I'm not going to expand that just yet. Let's do that first. And then I divide across by a, I get 8k squared over a. I plus 2k squared on both sides, I get xd as a subject. Yeah? Just solving that. Alright. Well, that's xd. Doesn't look that pretty because it's in terms of a. Okay. Yeah, right. Okay. But we forgot something here, that point B is also on the parabola, right? So we can basically plug these two coordinates into the equation here. So I'm just going to do that. So 4k all squared equals 4a, and then x is 2k squared. This will allow us to solve for k in terms of a or a in terms of k. Either one is fine because we want to solve this, right? Yeah. So the k squared cancel there. So I have, yeah, it's going to solve for a actually. So 16 equals k squared cancel. So I have also 16a here, right? No, that's not. That's 8a. Yeah, because it's only the 2k squared for ax. Yeah. Okay. So here a equals 2. Right? Well, that means xd is now, if a equals 2, we plug in there, right? So that's just minus 4k squared plus 2k squared, so that's going to be minus 2k squared. Yeah, that makes sense because it's a negative value, xd. Yeah, it's on the left side of the x-axis. So the area will be 1/2 times the base, and the base is just 2k minus, that's minus 2k squared. So 2k minus 2k squared, so that's going to be 4k squared times the height. So I mean, if we do that as the height, we're going to multiply that by 2 as well, because I'm doing maybe that and then multiply that by 2. So the height will be 4k, right? And then we're going to multiply all this by 2 because we get 2 triangles there of the same size. And I'm going to put that equal to 432. Yeah, 2 cancel here, so I get 16k cubed equal 432. So k cubed equals, what's that? 432 divided by 16, that's 27. Yeah. And then cube root of 27 is 3. Okay. There you go. Now we know k, so we can find the coordinates of b and c. So therefore, b, k is 3. So 3 squared is 9. 9 times 2 is 18. 3 times 4 is 12. And then c would be also 18 minus 12 because it's just the opposite. All right, so that's done for question 8. Question 9. This is vectors. So in the university level, they call it linear algebra. Yeah. And then number 9 here, the line L1 has equation R. Okay. So we have 2 vector equations of a line. Yeah. Line L1 and L2 intersect at point P. Determine the coordinates of point P. Well, basically we're just going to put them we're going to equate them. Yeah. So if I simplify the first vector equation, I'm going to get 2 plus 3 lambda minus 3 plus 4 lambda and 1 minus lambda. And I'm going to put that equal to 13 plus mu, 5 minus 2 mu, and 8 plus 5 mu. Yeah, like that. And now we need to find the solutions and validate that they all have the same solution, like the mu, the lambda are consistent. Yeah, so let's just maybe do the first one. So the first one, if we take the first equation here, if I simplify that, I'm going to get 3 lambda equals, moving 2 to the other side, I get 11 plus mu. Doing the second equation, I get 4 lambda equals 8 minus 2 mu. Okay? Yeah. So if I do the first one multiplied by 2 first, yeah, I'm going to get 6 lambda equals 22 plus 2 mu. And then with the second equation, I will add them like that. So I get 10 lambda equals 30, 22 plus 8. And then the 2 mu minus 2 mu will go away. So that means lambda equals 3 here. All right. And we're going to solve for mu already. So mu, picking the second equation, I get 8 minus 4 lambda divided by 2. Just using this one, yeah? You should be fine. And then that is mu equals, so 8 minus 12 is minus 4 over 2 is minus 2. And then if we plug it in to the third equation, yeah, 1 minus lambda being 3 equals 8 plus 5 mu being minus 2. If we get the same, like left and right hand side are the same, then it's consistent, so it's valid. So this is minus 2 equals minus 2. So there are solutions to lambda and mu. So lambda equals 3 and mu equals minus 2. Okay, that means the coordinates of P will be just found by substituting either lambda or mu in the corresponding vector equation. So in this case, I'm just going to use lambda maybe. So it's just P OP, yeah, vector equation. Coordinates of P will be 2 plus 3 lambda, minus 3 plus 4 lambda, 1 plus 1 minus lambda. So that's going to be 2 plus 9 is 11, minus 3 plus 12 is 9, 1 minus 3 is minus 2, right? That's the coordinate of P there, which is the same as the vector, position vector OP. Okay, part B. Given that the plane gamma contains both L1 and L2. Okay. So we have two lines that will be contained in a plane. So if that's line L1, that's line L2, and here you have the plane here that will contain both lines. Now, probably the easiest way to do this is to use the direction vector of the two lines, and you find the normal vector. So we can find the normal vector just by doing 3, 4, minus 1, the direction vector of the line L1, cross product with 1 minus 2, 5, which is the direction vector of the other line. We're going to get the normal vector of the plane, the n, yeah? So that's going to be done by I, j, k, the determinant of 4, 3, 4, minus 1, and 1 minus 2, 5, like that, okay? So for the I is 4 times 5, 20, 20 minus 2 is 18, so 18. For the j, yeah, I'm doing minor here, is 15 minus 1 is 16, and then we got to put a minus for the j. And then the k is minus 6, minus 4, that's minus 10. Yeah, got to be careful there. That's the vector n there for the plane. And now we're going to use, because this is Cartesian equation, so we're going to need this form. R dot normal vector equals some point on the plane dot the normal vector again. Yeah, we're going to need this form. R is just x, y, and z. Yeah, and so I can just put here x, y, and z dot product with the normal vector there equals, well, because, you know, if we take any of these points, so 2 minus 3 and 1, 2 minus 3 and 1 will also be on the line, hence on the plane. Or 13, 5, and 8 will also be on the second line and hence on the plane, because both lines are on the plane. So these 2 points must also be on the plane. So we can take either one of them. Yeah. So I'm going to take the easy number, the 2 minus 3 and 1, right? So 2 minus 3 and 1 dot with the also the normal vector there. Okay, gotta be careful. So that's going to be 18x minus 16y minus 10z equals, well, that's 36 plus 48 minus 10. We should simplify, of course. The right hand side is what? 84, 74, yeah? Ooh, how can we simplify this? So, can we do 2, yeah? Is 2 the best one? So if we do 2 for 74, it's going to be 37. So I think 2 is the best, yeah. Yeah, so that will be the Cartesian equation of the plane, right? Now part II here, determine the Cartesian equation for each of the 2 lines that pass through 0, 0, 0, make an angle of 60 degrees with the x-axis and make an angle of 45 degrees with the y-axis. So these are new two lines now, it's not the L1 and L2, okay? So there are three things we need to work on, passing through 0, 0, 0. So if we just put an arbitrary vector equation of a line, so we get a plus lambda b, like that, where b is just the direction vector of the line, right? A is just any point on the line, right? So as you can see, because it passes 0, 0, 0, so we can put that as 0, 0, 0 already. So here we just have the vector equation as some lambda times the directional vector. Now let's put directional vector as, I don't know, ABC, right? Yeah, ABC. And we're gonna find these ABC, yeah? Or we can just say that lambda b, yeah, together is just ABC, right? No, I'm just gonna do lambda for now, all right. And then we're gonna use the other two information here, which are actually very important, okay? So we use the directional vector here, and when it dot product with the x-axis, we're going to get 60 degrees. So we're going to use u dot v equals modulus u modulus v cos theta, right? We're going to use that equation. So u is just, say, the ABC dot the x-axis. We can use the basis vector I, which is 1, 0, 0. Yeah, that's the direction vector of x-axis, equals, well, let's say that the modulus of that vector b there, yeah, if I do that, the modulus is just going to be, let's say it's going to be d, right, just for simplicity there, yeah. So that's the modulus of the direction vector there. So it's going to be d times, well, where you can find it, right? This is just square root of the Pythagoras of all components, right? Okay, we'll just leave it there because we don't want to write a lot. And this is just going to be d times v, which is 1, right? Because that's the I vector. And then cos 60 here, yeah? So if we do the dot product there, we get A equals cos 60 is 1 over 2d, yeah? So it's 1 over 2 of the whole length, right? If we do the same for the second information, we do the same, so ABC dot product with the y-axis, which is 0, 1, 0, right? We get d again, yeah, times 1 again, times cos 45, which is 1 over root 2, of course, yeah? So that's going to give us b equals 1 over root 2 d. Yeah. Now we kind of know A in terms of D and B in terms of D now, but we also know that the A squared plus B squared plus C squared, we put it earlier to D. But we know some of them already, which is A squared, it's going to be half D squared, so that's going to be D squared over 4. B squared would then be D squared over 2, because that's D over root 2. And we want to find C here in terms of D as well, right? So if you look at these two expression, right, we square both sides, so we get D squared equals D, well, if we add these two, right, we're going to get what? 3 over 4 D squared plus C squared. So C squared is just a quarter D squared. That means we get C being plus or minus half D. That's why there are two lines here, because C can be either 1/2 or minus 1/2 D, right? So now we get the direction vector B, as we put early, as, what was the A again? 1 over 2, right? So 1 over 2D, 1 over root 2D, and plus or minus 1 over 2D. Or it's just some scalar value D, right? 1 over 2, 1 over root 2, plus or minus 1 over 2. That's the direction vector. Okay? So because we know, let's look at the formula sheet, right? In the formula sheet here, yeah, this is the AS, it's even in AS further mathematics, I believe it's also in A level there, here, yeah. It's kind of like the same effectively. So if A is the point with position vector that, and direction vector B is given by that, then the straight line through A and vector B has Cartesian equation. So this is saying to you that a vector equation of a line in a Cartesian form, where A is, let me just bring that form back, A plus lambda B. A is just this guy, and B, the direction vector, is just this guy, right? So you can do x minus, well, because this is just what? 0, 0, 0, right? Remember, because it passes origin. So that will just be x alone, no minus there. Divided by the x component of the vector b, which is b1. So in our case, we got it to be 1 over 2, right? So, I mean, we can do 1 over 2d here, yeah? And it will simplify, but just for the working here. And what's next? Y minus 0 and over 1 over root 2d equals z over plus or minus 1 over root 2d as well. Now d simplifies, right? Now I'm going to go back to the question. D simplifies, you can cancel all d out, so you're going to have what? 2x and move 2 up equals root 2y equals plus or minus 2z. Yeah? So I think that's it. You get so you get one equation to be 2x equals root 2y equals 2z, or 2x equals root 2y equals minus 2z. That's it. That's the two equation there. Yeah, I'm just going to leave like that. And that's the answer. Okay? Next question, number 10. Yeah? Okay. The motion of a particle P along the x-axis is modeled by differential equation that, where P has displacement x meters from the origin O and at time t minutes t greater than 0. A, show that the transformation x equals tu transforms the differential equation I into the differential equation that. Alright, so this is second order differential equation still, and we need to solve it for the particular solution later on. Okay, so yeah. The easiest way is to just differentiate x respect to t, because we're going to substitute d squared x by dt here and dx by dt here. So dx by dt using the transformation equation, we're going to have to do the, because u is also a function, so yeah, dx by dt we do a, so t du by dt product rule plus u, right? dt by dt is 1 and then u. Okay, and then we differentiate again, so that's second derivative of dx by dt. Yeah, just differentiating this again. So product rule for that, so t second derivative for du by dt there, plus the product rule first, so dt by dt is 1 and then du by dt not doing anything. And then this one we differentiate respect to t, so we get du by dt as well. So that simplifies to t d squared u by dt squared plus 2 du by dt. Alright? And then we're going to substitute to the equation I here, everything. So that's going to be I t squared dx squared by dt squared is just this whole guy. We're going to substitute the whole thing in. Plus 2 du by dt, yeah, minus, this is still fine, nothing to substitute here, but dx by dt, yes, it's going to be t du by dt plus u, right? And then I have down here plus 2 t plus 1, we need to sub x as tu equals 8t cubed e to the t. Okay, right? So let's simplify that. Well, by the looks, because I noticed, right, the right hand side changes from having t cubed to not having it. So I'm going to suspect that we need to divide across everything, every term by t cubed. And I'm gonna do that already here. So divide by t cubed here. So the first term become, well, you got t squared here already, right? So that's so after you multiply t squared to this, you get t cubed. So the first term will be without any t. That's what we expect here, the first term. And then the second term you multiply into this, you're gonna get 2 over t, yeah, du by dt, because you're multiplying across by t cubed. Well, what about the next one? This is 2t squared. Well, that's a lot of terms, huh? Okay. So, okay. Let me just do 2t squared plus 2t divided by t cubed, and then that first, right? And then here we have plus. That's the same. So I'm just going to cut one t out with the tu there. So I have this times u divided by t squared. And then here we have 8e to the t. Yeah, just aiming for that first. I believe it's going to simplify, right? So we need to seek simplification here. Seems like we're only going to have du by dt left. So that means other terms should cancel. Like, okay, so yeah, hang on. So for this one, I can cut one t out, right? So let me just simplify that by just removing that, removing this t, and this is 2t to the power of 2, okay? And then, yeah, and then if you multiply in there, you're going to get also over t, and then, okay. So if I expand everything, but not totally expanding everything, it's just expanding some term there. So if I expand this to this, yeah, I'm going to get, let's see, well, that's also, yeah, okay. Okay. So that will be minus 2t over t squared times t du by dt. That's just this bit multiplying with this, yeah, I get this. Like I split the fraction first, and then I multiply the first partial fraction to this inside, all right? And then there's another term minus. Similarly, 2 over t squared, just this partial fraction here with a minus sign expanded, times t du by dt as well. You know, actually I can already simplify here, this another t here, so, oh no, I can't. Okay, just leave it like that. And then the u term will be minus 2t plus 2 over t squared times u. And there's another one here plus 2t plus 2 times u. You see that they are the same, right? So this one and this one are the same term. Yeah? So they can cancel that. That's why I don't expand everything yet. Okay? Because there will be a lot of work there if you do. Now, as you can see, right? There's some simplification here we can already do as well. So t cancel that. That t and this cancel. So this term will cancel with this term, right? So we have left d squared u by dt squared minus, yeah, we expect that, du by dt. So it's just this term that remains. And then, yeah, that's it, because d is cancelled, so we get it. There you go. All right, just algebra there. Got to be careful. And then part B. Given that P is at O when t equals ln 3 and when t equals ln 5. So at O means the origin, right? So x equals 0 there. Okay. Determine the particular solution of the differential equation. So we solve everything, right? So we got to do complementary solution first. So yc, yeah. Well, let's just do m squared minus 2m equals 0 first. So that's just, you have done it before, right? This is just to find the complementary solution for second ODE. So there are two real roots here. Yeah. So m equals 0 or 2. So 2 real roots, right? So the y complementary function would be a e to the 0x plus b e to the 2x. It's not x, right? It should be t, sorry. Yeah. Okay, and this should be x, right? This should be, sorry, u, because we are solving for u first, right? Okay, so yeah, it's just, so because this is 0, so that's just a plus b e to the 2t. Yeah? All right, so that's our complementary solution. And now we will also look at the particular integral. So we try particular. This is 8e to the t, so we just do, lambda e to the t as well. Yeah, should have to be the same exponent there. Okay, now if we put everything into this, right? So we do du, so u will be dA u complementary plus up, which is a plus b e to the 2t plus lambda e to the t. And now we do du by dt. Yeah, it's gonna be, so that's just 2b e to the 2t plus lambda e to the t, doesn't change here. And then again, d squared u by dt squared equals 4b e to the 2t plus lambda e to the t. Okay, now we're gonna substitute everything. Yeah, so the second order would be, we substitute the second derivative to the second derivative, so that's 4b e to the 2t plus lambda e to the t, yeah, minus 2 of du by dt, 2b e to the 2t plus lambda e to the t equals 8 e to the t. This is just to find the constant, right, or the constant term. So if we expand everything, we can see that there are two types of term, e to the 2t and e to the t. So the e to the 2t is 4b minus 4b e to the 2t. Now that's gone. So that will, allow us to solve for lambda alone. So plus, yeah, we'll solve lambda first here, and then we will use the boundary, the initial conditions to solve for a and b. Right, so let's solve for lambda first here. So this is what? Lambda minus 2 lambda, right? Yeah, because 2 expand here. And then e to the t equals 8 e to the t. So we can say that lambda, that's lambda minus 2 lambda, so that's minus lambda equals 8. So lambda equals minus 8. Okay, so that's the particular solution there. That means now we have u equals, we don't know a yet, we don't know b yet, we're going to get them by just the conditions. But we know the particular integral already. Now we get the general solution now, where a and b are still to be found. So, but this is the u, the transformed equation. So if we put that back to x, right? So x will be ut. So it's just t times the whole thing, yeah? Which is just that. Okay, and then we just try put in the conditions there, given that p is at origin, which is x0. Yeah, so x0 at t equals ln 3 or ln 5, right? So we're gonna just do that, right? So 0 equals ln 3 times a plus b e to the, so that's 2 ln 3, which is ln 9, right? Because you put 2 as a power of ln 3 there in the 3, and then this is 8 e ln 3. Yeah, so what am I getting here? 0, well, ln 3 can cancel that, so I get a plus 9b minus s minus 24. Yeah, okay, and then for the other condition, right, as well, 0 equals ln 5, just gonna write everything again, b ln e ln 9 e to the ln 5, right? no, not ln 9 here, ln 20, hang on, it's 5, so it's 25 here, right? Yeah, isn't it? It's ln 5 and then you have a 2 there, so it's 25, yeah, 25. Okay, so that's going to be 0 equals, ln 5 cancels again, a plus, this is 25b minus, that's 5 times 8 is 40 here. Yep, and then we can subtract the two equation, I guess. We subtract the two equation, we get 0 on the left still, 8 disappear, we get minus 16b here, and minus 24 minus 40, so that's 16. Okay, so b is just easily 1. If b is 1, then a, solving a, we just plug b back in here maybe, so 1 plug in there, so we get 25 here. This is minus 15 then, so a will be 15, right? That means the particular solution, u, is going to be, right? Well, let's just say, because we want to solve for x in terms of t anyway, so x equals t, and then we're going to look at this one here, yeah? So a is 15 plus b is 1, so that's e to the 2t minus 8e to the t. So that will be the answer there. That's done. So I hope that was all useful for you guys, and just give me a comment if you have any question, and I'm gonna expand my content to cover further maths as well. This is just the beginning here, and I will do other modules, of course, like core pure, statistics, mechanics as well. I'll see you in the other videos. Thank you. Bye.